Yeah, I'm sharing my screen. Today we'll discuss about the serial adder. Okay, what is the serial adder and how to design the serial adder and so how to get the FSM. I will design the serial adder by using Mealy machine. Okay, so serial adder by using Mealy machine and also we'll see the Verilog code for the serial adder. Okay. So if you see the serial adder, so basically parallel adders are nothing but ripple carry adder, carry look adder, and BCD adder. Those are nothing but parallel adder. So we are using these parallel adders. We are using four full adders and like that. The serial adders are nothing but wherever you need. That means that speed is not that much requirement. Okay. So this consists of less logic circuitry and this is slower than the parallel adders. But cost wise, it is less cost only compared to parallel adder. So serial adder means bit by bit you are sending the data and you are getting you are sending and you are receiving the output. Okay, so how the serial adder will look like means it will be look like serial adder. So serial adder will be look like this. Suppose you have one shift register. This is one shift register and this is one more shift register. Okay, this is one more shift register. So shift register. Here from the shift register, I'm getting A input. Okay, add and and augend. Okay, normally if you see A plus B, so this is nothing but add and this is nothing but augend. Okay, and this is one more shift register. This is one more shift register, and from here you are giving the augend. Okay, B. You are giving B. Okay, and next you have adder FSM. Okay, adder FSM, finite state machine. Okay, so adder FSM. In adder FSM, you are giving this A to this adder FSM and this B to adder FSM. Okay, common clock is given to the shift register. Okay, normally this shift register is nothing but you are using SISO. Serial in, serial out you are giving. Okay, and common clock is given like this. Common clock is given like this. Okay, so here. Uh, So this is common clock for this FSM, and you are getting some. You are getting some, and this is one more shift register. This is one more shift register for storing this sum. Okay, and here also common clock is given to this shift register. Okay, and here from the shift register you are getting the sum A plus B. Okay, so this is the basic block diagram for serial adder. Okay, so serially suppose if you want to add 1010 and double one. Okay, so that means first here this will be shifted. Okay, this will be shifted and this will be added. That means first 0 plus 1 will be added and that will be stored in the shift register. 0 plus 1 means what? 1. Okay. So after that, next second bit is there. Second bit will be added, and so it will be gone so through the adder FSM. And when it is saving the shift register, this will be shifted towards right. So 1 will come here, and 1 plus 1 is nothing but 0. Like this, 1 bit it will be shifted. Okay, 1 bit will be stored in this shift register. Okay. So you already know that what is Mealy emission and Moore emission. So now Mealy emission is nothing but Mealy emission, Mealy FSM. I think you have idea. Mealy. So the output is what? Output is function of what? Present state and present input. Present state and present input. Okay. So how the state diagram will look like means you have this is state, this is state, and you have so like this it will be there. Okay, so this is a input by output, input by output. Okay, like this the state diagram will look like. So it will go into other state. Okay, other state, this is input by output, input by output, and this is one more state, one more state. Okay, so now I am designing the Mealy type serial adder. I am designing the Mealy type serial adder. So Mealy type serial adder. So how you will design means first you write the you write the truth table for full adder. Okay, you write the truth table for what? Full adder. Okay, so we already seen the full adder in the combinational circuit. Okay, so full adder circuit. So full adder how many inputs? Three inputs, no? A, B, and C in. Okay, so three inputs are there. How many possible combinations? Eight possible combinations are there. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 101, 110, and 111. Okay, so that means here, so you have like, so in this, you have sum and carry out. So when it is 0 plus 0 plus 0 means some 0 carry 0, and here some 1 carry 0, here some 1 carry 0, and here some 0 carry 1. This we already seen in the full adder circuit. Okay, so this is some 1 carry 0, some 0 carry 1, some 0 carry 1, and some 1 carry 1. Okay, so that means here you need to consider. Let us take these are the inputs. Okay, these are nothing but inputs. Okay, inputs, and this one is nothing but we consider as present state, and this one is nothing but carry out is nothing but next state. Carry out is nothing but next state, and this is my output. This is my output, some output. Okay, so there are two states are there. So what are those states? That states are that states are G and H. Okay, that states are what? G and H. Okay, G and H. Okay, G and H are the states. Okay, states. So what is G? G is nothing but this relate to carry in. Carry in equal to what? 0. Carry in equal to 0. Okay, so carry in equal to 0, that is G, and H is related to what? Carry in. Carry in equal to what? 1. Okay, this is carry in. Okay, carry in equal to 1. So from here I can write. So these are the inputs. This is nothing but present state. No, this is my G. Okay, and carry out also I need to consider. This is also G. Okay, and this is what? This is H, and this is G. Okay, and this is what? This is G, and this is also G, and this is H, and this is H, and this is G, and this is G, and this is H, and this is H, and this is G, and this is H. Okay, this is H, and this is H, H, H. Okay, H, H. Okay, so from this truth table, I'm drawing the state diagram. Okay, so how I'll draw the state diagram? State diagram. State diagram I will draw. So here how we'll draw? So this is G, this is G, and this is what? H. Okay, this is what? H. Okay, first you see. So you are at G. What is the present state is G. What is the next state? G only. Okay, it will be in the same state. It will be in the same state. This is like input by output. Input by output means this is AB by S. AB is nothing but input and S is nothing but output. Okay. So what is the input? Input is 0, 0. Input is 0, 0. And so here I will draw like this. One second. Mm, here. See here. So this is what? Input is 0, 0. What is the output? 0 only. Output is 0. Okay. And next you see. You are at H. You are at H. Okay. What is the next state? Next state is nothing but it is coming to G. Okay. So you are at H. Next state is G. Next state is G. And what is the input? Input is 0, 0, and output is 1. Output is 1. Okay. So this is over and this is over. Next one you see. You are at G, and what is the next state? That is the same state. Okay. So same state. It will be in the same state only. And what is the input? 0, 1. What is the output? 1. What is the output? 1. Okay. And next, next, this is over. Next, you are at H. Okay, you are at the state H. It will be in the same state only. It will be in the same state only. So that means it will be in the same state only. Input is 0, 1. What is the output? Output is 0. Output is 0. Okay. Output is 0. Okay. This is also over. And next you see, you are at G. It will be in the same state. What is the next state? Same state. Okay. So what are the inputs? 1, 0, 1, 0. And what is the output? Output is 1. Output is 1. Okay. And this is also over. Next you see, you are at H. You are at H. What is the next state? It will be in the same state only. Okay, it will be in the same state only. And what is the input? Input is 1, 0. Output is 0. Output is 0. Okay, this is over. Next, you are at G. Okay, present state is G. What is the next state? It is coming to the H. It is coming to H. What are the inputs? Uh, Inputs are 1, 1, and the output is 0. Output is 0. Okay, and next is this is over. And next you see. So next this one, this you see, you are at H. It will be in the same state. Okay, what is the input? Input is 1, 1, and the output is what? Output is what? Output is 1. Output is 1. Okay. So like this, I got all the possible combination. That means you need to see. That means at G, you need to see the possible combination of input 0, 0, 0, 1, 1, 0, 1, 1. Okay, I all got no 0, 0, 0, 1, 1, 0, and this one is 1, 1. Okay, from H also you need to see all the possible combination 0, 0, 0, 1, 1, 0, 1, 1. I need to see all the possible combinations. Okay, and next what you need to do? You need to draw the state table. Okay, you need to by seeing the state diagram, you need to draw the state table. Okay, so how I can draw the state table? See here. So this is my state diagram, no? By seeing the state diagram, I need to draw the state table. Okay. So here, one second. Yeah. So yeah, place will be visible. Okay. So state table I am drawing. State table. So state table. How I am drawing the state table? Here, suppose present state, and inputs. Okay, inputs are nothing but ab. Input is ab. Okay, and next you have next state, and here this is output. Okay, output. Okay, so here next state is ab, 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 and ab. Okay, so here I need to write 0, 0, 0, 1, 1, 0, 1, 1. Okay, here also output output is what? ab, 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 and AB. Okay. So 0, 0, 0, 1, 1, 0, 1, 1. Okay. 1, 0, 1, 1. So you need to draw the state diagram. So you are at G. You are at G. Okay. Now you see here. So by seeing the state diagram, you need to draw the state table. Okay. So see here. When input is 0, 0, what is the next state? Next state is G. Okay. When input is 0, 1, what is the next state? G. When input is 1, 0, next state is G. When input is 1, 1, next state is H. Okay. And what is the output? Output is 0, 1, 1, 1, 1. And next it is going to this H, the output is 0. Okay. And you are at H. You are at H. Okay. And need to see for 0, 0. 0, 0 means what? What is the next state? It is going into G. It is going to G. And when it is 0, 1, the next state is H. And the next state is 1, 0 means next state is H only. 1, 1 means next state is H only. Okay. And next, what are the outputs? First output is 0, 0 means the output. This is the output. Output is 1. And here next output 0. And next output 0. And next output 1. Okay. So this is my state diagram. And next, by seeing the state diagram, you need to draw the state assignment. By seeing the state table, you need to draw the state assignment table. Okay. So how you will draw the state assignment table? So So you need to give the state values. So that means G I am giving as 0 and H I am giving as 1. You need to give the values, state values to these states. Okay, G I am assigning as 0 and H I am assigning as 1. I need to draw the state assignment table. Okay, so this is my state assignment table. State assignment table. So state assignment table if you draw. So this is my present state. Okay, present state and input is what AB, okay, and next state is Y, okay, and output is yes, okay, and here AB and AB, and here also AB, and AB, okay. So here if you see, uh, so by seeing this state table, I am drawing the state assignment table. So G means what? 0. Okay. Here G means what? 0, 0, 0, 1. Okay. Here 0, 1, 1, 0. Okay. And H means what? 1. This is 0, 1, 1, 1. And here 1, 0, 0, 1. Okay. State assignment table I drawn by seeing the state table. Okay. After state assignment table, next you need to draw the expanded state table. You need to draw the expanded state table. So how to draw the expanded state table? So this is my state assignment table. So expanded state assignment table. Expanded state assignment table. State assignment table. Okay. So how to draw the expanded state assignment table? You have a present state, present state, and inputs. So what are the present state and inputs? Let us take y, y, comma, a, comma, b. Okay, these are the present state. Okay, present state. And the next state, this is next state. And next you have output. Okay, so what are the present states? Here, y, a, b, y, a, b. Okay, and let us take the next state is y plus is the next state, and s is nothing but the output. Okay, so YAB means what? How many possible combinations? 8 possible combinations. 0, 0, 0, 0, 0, 1. Okay, and 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so by seeing this state assignment table, I need to draw the expanded state assignment table. Okay, so that means here you see. So when the input is 0, 0, okay, here you see. This is 0, 0, 0, 1, 1, 0, 1, 1. Okay, this is also 0, 0, 0, 1, 1, 0, 1, 1. Okay, and this is present state. Present state. Okay, so uh, so when it is 0, 0, 0, what is the next state? When present state is 0, inputs are 0, 0. What is the next state? 0. What is the output? 0. Okay, this one, and this one. Again, when the input is 0, 0, 1, okay, present state is 0, and the input is 0, 1. What is the next state? 0. Okay, this one. And what is the output? Output is 1. Okay, this one. Okay, and next 0, 1, 0. 0, 1, 0 means what? What is the next state? 0, 0. And what is the output? 1. Okay, and next 0, 1, 1. 0, 1, 1. What is the next state? 1. And what is the output? 0. Okay. And next you see. Next 1, 0, 0. 1, 0, 0. Present state and input 1, 0, 0. Next state is 0. Next state is 0. And output is 1. Output is 1. And next 1, 0, 1. 1, 0, 1. What is the next state? 1. Output is 0. This one. This one. Okay, and 1, 1, 0. So that means input in next state is 1, and output is 0. Output is 0. Okay, and next 1, 1, 1. So next state is 1, output is also 1. Okay, so I got the expanded state assignment table. So I need to draw, I need to write for this y plus, I need to draw the K map and I need to get the logic expression. Okay. So y plus equal to what? Summation of m of, what are the minterms? This is 3 and this one is 5, 6, 7. Okay. So 3, 5, 6, 7. Okay. 3, 5, 6, 7. So if I draw the K map, if I draw the K map, so here inputs are y, a, b, 0, 0, 0. 1 second. This is 0 only. This is 0 only. Okay. So, yeah, this is 0 and 1. 0, 0, 0, 1, 1, 0, 1, 1. Okay. 0, 0, 0, 1, 1, 0, 1, 1. Okay. So, 1 second. Yeah. Next, you see here what you are getting. 0, 1, 0, 1. Yeah. Yeah. So, see here 0, 1. Next, 2, 3. Next, 4, 5. 6, 7. Okay. So 3 is 1, 3 is 1, 5 is 1, and 7 is 1, and 7 is 1, and 6 is 1. Okay. So this is one pair, and this is one pair, and this is one pair. Okay. So that means if you see here, this one is nothing but YB, AB, and this is Y, YA, YA. Okay. So what you will get the expression y plus y plus equal to what? So ya plus yb plus ab. This is my expression. Okay. And next, you need to draw the k map for what? A sum also. Sum also. So that means this is 0, 1, 2, and 3. 3, 4. Okay. So what is sum? Sum equal to what? Sum equal to summation of m of, what are the minterms? 1, 2, 4, 7. Okay, 1, 2, 4, 7. So if I draw the K map, if I draw the K map, what I am getting? This is Y, A, B, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. Okay, 0, 1, 2, 3. Next, 4, 5, 6, 7. Okay, so here, what are the minterms? 1, 2, 4, 7. So if you are getting like this diagonally, that is nothing but XOR gate. Okay, or otherwise you can do also. Okay, so sum equal to what? Sum equal to A XOR B XOR Y. A XOR B XOR Y. This is nothing but my sum. Okay. Now I can draw the Mealy serial type, Mealy type serial adder. Okay. So how I am drawing? See here, one full adder is there here. One full adder is there. Okay. One full adder is there. So this is my full adder. Full adder. And next here this is A and this is input B. Okay. And here I am getting sum. Okay. What is sum? We'll see. Okay. And here this is nothing but my let us take Y plus next state. Next state Y plus. And here I am connecting the D input, D flip flop. Okay. So this is D and Q, D and Q, and clock I am giving. Okay. Clock I am giving, and I am giving asynchronous active low reset. Okay. This is nothing but asynchronous active low reset. I am giving reset. Okay. And this is my present state. Let us take present state. This will be feedback to the input. This will be feedback to the input. Okay. Now what is my sum? Sum equal to what? Sum equal to A XOR B XOR. What is the input? One input Y. Y. Okay. So sum equal to what? A XOR B XOR Y. I got no. So I got the same expression in this A XOR B XOR Y. And this is my D flip flop. D flip flop. Okay. So next carry out. So y plus equal to what? So y plus equal to so ab plus ay plus by. AB plus AY plus BY. Same thing, no? So AY, so AB, so you can write like this also. So AB plus AY plus BY. AB plus AY plus BY. So you got, so like this, you need to design the serial adder Mealy machine. Okay. Now we'll go to the programming part. One second. I'll open the programming part. Mm, One second. Verilog programs, serial adder. I'm opening Vivado. Meanwhile, I will create here 1 second. I will create a serial adder. I created or not, I will see. Okay, serial adder. Serial adder not created. Okay, I will create one folder. Serial adder. This is my serial adder. Yeah, this is my serial adder. Okay. So serial adder. Okay, serial adder. And in this folder, I will create two folders. One is RTL, and next one is TB. TB. Okay, TB, and next one is sim. Next one is sim. Okay, simulation. Okay, so I created this folder, and after that I opened this the link Vivado, and here serial adder Mealy is there. Okay, so as this is not visible, just I'm copying this and I'm opening GVim. Okay, GVim. Just I will paste here. Okay, just I will paste here, and whatever our module name is there, that I need to save. Okay, serial adder, serial underscore adder underscore Mealy. Just copy this file, save, and so my folder, what is my folder? RTL codes, serial adder. In RTL, I'm saving this file with the .v extension. Save this file. Okay, it is saved. It is saved. Okay, this is my serial adder, and I am increasing the font size. Okay, and test bench also I will save. How I will save test bench? Here I wrote in simulation part serial adder Mealy. Okay, serial adder Mealy. Okay, just copy this, and I'm opening one more GVim. So just paste this. Okay, paste this, and so what is my module name in the TB underscore Mealy underscore serial. Just to copy this file, save. So I need to save in where TB. So TB save .v. Okay. So if it is SV means you need to save in terms of extension .sv. EVM also you need to save like the .sv only. So this is my test bench. Okay, in TB I saved the test bench. Okay, first we are going to the programming. Okay, this one font size I need to increase. Edit, select font size and increase to 16. Okay, you see here. So that means based on the state diagram only, I wrote the serial adder. Okay, where is my state diagram? See here. So I told how you get the state diagram from the full adder truth table only. You will got the state diagram. Okay, this is my state diagram. Okay, so based on the state diagram only, I'll write the code. Okay, see here, serial adder. First module, and my module name is serial underscore add underscore Mealy. And what are the inputs? Input wire clock, input wire reset, input wire A and B. A and B are the inputs now. Input wire A, input wire B, and some I need to initialize with reg. Why? Because I'm using behavioral modeling. That's why some you need to initialize with output reg sum underscore out. Okay. So I initialize the input and output. After that, you need to define the that G and H. Okay, I'm defining with parameters. Okay, parameters state underscore no carry is what one tick binary 0. This represents carry in equal to 0. So that means what is this in my diagram? G. G represents, this is nothing but the state when carry equal to what? 0. Okay, when carry equal to 0, this is nothing but my state. Okay, and next you see parameter state underscore carry one tick binary 1. This represents the carry in equal to 1. Okay, so that it means H equal to what? H is nothing but carry in equal to 1. Okay, carry in equal to 1. And after that, current state. So current state register is what? Reg current state, comma next state. Okay. So actually, current state is sequential in nature, and when you write the program in FSM, current state is sequential in nature, and next state logic is combinational in nature. Okay. So here I wrote that means sequential logic for state transition. So always at the rate passage of clock and negate of reset. Why? Because you are using asynchronous reset. That's why I'm using passage of clock or negate of reset. Begin. If not of reset, if current state, okay, if current state, that means state no carry. So if it is in current state, state no carry. So that means it reset to no carry. Else, if and end, else begin, current state is as initialized to next state. Suppose if you are getting a carry, it will be in the same state only. If you are not getting a carry, it will go to the next state. It will go to the next state. So carry equal to 1 means it will go to the next state. Okay, that is the meaning of this. Okay, so next state. Okay, this is sequential logic for transition and combinational logic. So if you see the combinational logic for next state and output, that is combinational. Okay, for next state and logic, I'll write for the combination. Always at the rate current state or A or B. If there any change in the current state or any change in the A or any change in the B, okay, next state equal to what? Current state. Okay, next state equal to current state and sum out equal to what? One tick binary 0. Okay, so that means next state equal to current state and what is the output? One tick binary 0. Okay, this is the next state logic for my Mealy FSM. Okay, now when you are in current state, state no carry. No state no carry. So when there is no carry, I'm using a case statements. Okay, so that means first state. What is the first state? 0 plus 0 plus 0. Some 0 carry 0. Okay, some 0 carry 0 means if you see here for first state, okay, it will be in which state? Same state. 0 plus 0 plus 0, it will be in the same state. Okay, see here, so that means it will be in the same state. Okay, so that means next state is no carry. 0 1 means what? Next state is equal to what? No carry. Okay, and that is nothing but 0 1 0. Okay, 0 1 0, 0 1 0 sum equal to, so that means if you see the diagram, 0 1 0. Okay, that is the this one. You see the diagram and table. 0 1 0, it will be in the same state. No, it will be in the same state. Okay, so when it is 0 1 0, it will be in the same state only. Okay, so in next state equal to state no carry and sum equal to what? 1. Sum becomes what? Here sum becomes 1. See here, sum becomes 1, this one. Okay, this one. And next you see if it is 1 0, if it is 1 0, 1 plus 0 plus 0. Okay, 1 plus 0 plus 0 means what? Carry equal to 0. No, so carry equal to 0 means what? Next state equal to state no carry. So if you see the diagram, 1 0 0, it is in the same state now. It will be in the same state. Okay, so it will be in the same state. And next I wrote so begin next state equal to state no carry and sum out equal to what? 1. I'm getting 1 plus 0 is 1, carry equal to 0. I'm checking the 6 also. 6 state. What I will get? So present state is G. It will go to the next state H now. So that means 1 plus 1 plus 0, 1 0 you are getting. That means sum 0 and carry equal to 1. Okay. So next state equal to state carry. So state carry means what? State carry means that is nothing but H. It is going from G to H. Okay, G to H. Okay, here I checked for this one. This is for carry in equal to 0. Okay, for 6 also you are getting carry in equal to 0. See here. For 6 also you are getting carry in equal to 0. This is G. First I am checking carry in equal to 0. Next I am checking carry in equal to 1. Okay, separately by using if case statement. Okay, yeah, see here. Next, state carry. State carry means what? Carry in is equal to 1. Okay, case concatenation operator A comma B. If it is 0, if it is 0, okay, 0 plus 0 plus 1, that is equal to what? 1, carry 0. Okay, so which state I am checking? That is 0, 0, 1. If it is H, it is coming to what? State carry. Okay, it is coming to G. Okay, if it is H, it is coming to G. Okay, see here. So that means next state equal to what? State no carry. Means what? G. State no carry is nothing but G. State carry is nothing but what? H. Okay, and sum out equal to what? One tick binary 1. Okay, by seeing this diagram, you need to analyze. Okay, see here. If you see the diagram, this one. Okay, this one. Okay, and next you see when it is 0, 1, 1, you are getting 1, 0, some 0, carry 1. So that means 0, 1, 1 means what? Begin next state. That is state carry. So 0, 1, 1. So that means present state is H. It is going to the next state, same state. Same state. Same state means what? Next state equal to what? State carry only. Next state equal to state carry. And next, 2 tick binary 1, 0. 1 plus 0 plus 1. That is 1, 0. Some 0 carry 1. Okay. Some 0 carry 1 means 1, 0, 1. This state you see. So present state is H. What is the next state? It will be going to H only. Okay. So it is going to H only. So that means I can say that next state equal to what? State carry only. Next state equal to state carry. And if it is 1, 1, okay, if it is 1, 1, 1 plus 1 plus 1, that is 1, 1, sum equal to 1, carry equal to 1. Okay, sum equal to 1, carry equal to 1. So you see, so if you see, so 1 plus 1 plus 1, 1 plus 1 plus 1 is nothing but what? Carry in is 1 and sum is 1. So what is the next state? State carry. What is the next state? That is nothing but state carry only. Next state equal to what? State carry. And sum out equal to what? 1. Okay. So next state logic I wrote with combinational logic. Okay, next state logic. And I told, so you know that if we are using case statement, that should be default statement will be there. That should be default will be begin state. Okay, it should not happen with one bit state. Next state equal to state no carry and sum out equal to one tick binary end and end case end module. Okay, so like this you need to write the Verilog code for serial adder Mealy machine. Okay, so coming to the test bench. So this is my adder circuit, and whatever the inputs are there, I need to initialize with reg. These are the inputs: clock, reset, a comma b, and wire is nothing but sum comma count. And I need to instantiate the design. How I'm instantiating? By connection by name. Okay. So this is my design name: serial underscore adder underscore Mealy unit under test. Whatever the variables outside outside these bracket are nothing but design inputs, the inputs and outputs. Whatever the variables inside the bracket are nothing but test bench inputs and outputs. Okay. Next, I need to generate the clock. Okay. Initial clock equal to 0 forever, not so hash 5 clock equal to not of clock. I'm generating the clock with how many nanoseconds? 10 nanoseconds. Okay. End and initial. Okay. Reset equal to 0. So when active low reset, no. So when reset equal to 0, I'm making A equal to 0, B equal to 0. After 10 time minutes, I'm making reset equal to 1. So this is nothing but reset mode. After 10 time minutes, I'm making into functional mode. Okay. I'm checking for the test cases. What are the test cases? I'm checking for the addition. A equal to 1011 and 1101. Okay. So 1011, 1011 is 11. 1101 means what? 13. Okay. So I'm checking for this. That means what output I will need to get. I'm giving A equal to what? 1011 and B equal to 13. 1101. Okay. So normally, theoretically, if you do 1 plus 1 is what? 0, carry 1, 0, carry 1, and 0, carry 1, 1, 1. Okay. So normally 11 plus 13 is 24. 24 means 1, 2, 4, 8, 16. 24 you got, no? So this you need to get. Okay. This is my sum you need to get, and this is nothing but carry. Okay. This output I need to get when I simulate this. Okay. So I will see in the Xilinx Vivado. So I said this, I explained this code only. Okay, FSM serial adder Mealy, FSM serial adder Mealy, and this is Mealy test bench. Okay, so whatever you are simulating, that you need to make as top module. Run the simulation, run behavioral simulation. 1 second. Launch earlier error. So okay. Mm, okay. 1 second. Yeah, this I need to make a stop model. Let us stop Mealy. I'm getting or not, I will see. Mealy and serial adder Mealy. Run simulation, run behavioral simulation. Okay, I'm not getting where I'm getting the error to serial adder. Adder dot detecting the errors. Cannot find port iota. Okay, I will remove this. Okay, which one? Mm, iota. Okay, I will remove this more and I will see. 1 second. AB sum underscore out. Okay, so just I'm simulating. 1 second. I'm getting errors. Okay, cannot find. 1 second. Okay, so in the TB, reset only, no? Reset. Okay, yeah, 1 second. Yeah, 1 second. Yeah, see here. I got the output. One second, I'm sharing. So here you see, data out is I'm taking D6. So here, if you see, so data is how many bits I am taking, D6 I am taking, and data B is how many bits I am taking, 6, and I am checking for sum. Okay, so sum what I am getting. Okay, here I'm checking for serially. I'm checking for some for each and every clock pulse. I'm checking for. Suppose here you see. So, yeah, so initially this is reset. Okay, reset equal to 0 means what? So it will be in reset mode, and it is going from reset mode to functional mode during the passage of clock only. A is 0, B is 0. Okay, A is 0, B is 0 means what? Sum is a 0. Okay, sum you are getting 0. Okay, and here during this passage of clock, if you see, so A is 0 and B is 1. You are getting sum is 1, no? Serially it is adding. Okay. And during this passage of clock, what happens? A is 1, B is 1. You are getting sum equal to 0, you are getting. Okay. Sum equal to 0. And similarly, during this state, during passage of clock, A is 0 and B is, A is 0, B is 1. One second. A is 0, B is, A is 0, B is 1. 0, 1, and some you need to get 1. No, okay, one second. We need to, I think we need to see it in the negage of clock. So 1, 0 means during negage of clock only. 0, 1 means you are getting some of 0. Okay, if I need to see. Okay, okay. So when it is 1, 1, we are getting some 1. Okay. Yeah. So this is about the simulation. Okay, I will see and tell you. Okay.